All right, everybody. Time to talk about the producer and consumer's surplus. Okay. And it's yet another application that we use the definite integral to calculate. All right. Um, and I, what you see here are supply and demand curves or graphs. Okay. And I'm not going to explain a whole lot about that in this video. I thought if in this video I explained what the consumer surplus was, what the producer surplus was, why we calculate it this way. I thought if I explained all that in addition to showing you the math, it would clutter up the video too much. So I'm not going to say a whole lot about this picture here. Besides that, it is the supply curve or graph and the demand curve or graph together. Okay. And what those tell me, well, think about this supply. I see supply, I see price, I see quantity, I see demand. Let's think about it like this. In the marketplace, there are people that supply the products and there are people that buy the products. Economists call that demand, though. Okay. Demand is what the consumers in the marketplace are willing to buy, how much they're willing to buy. Okay. The supply curve, notice that even if it's not a line exactly like this, even if it does have some curvature to it, will go up and to the right. And that is because all the points on the supply graph represent, okay, at various prices, the quantity the supplier is willing to put on the market. All right. So, like, why does the supply curve go up and to the right? Well, because the higher the price is, the greater the quantity is that they're willing to provide for consumers. Okay, and here's the demand curve or graph. Why does it go down and to the right? Well, because they have the opposite incentive, basically. Um, that for anybody willing to buy, it's a law of supply and demand, basically. That the higher the price is, okay, the less people are willing to buy, all other things being equal. I'm not saying there aren't other factors that influence how much suppliers are willing to supply and how much consumers are willing to buy. But in general, the laws of supply and demand say that for suppliers, as the price goes down, they're willing to supply less. And for consumers, as price goes down, they're willing to buy more. Okay, so that explains. I mean, I said I wasn't going to talk a whole lot about this, but look at me. That explains a little bit about the nature of the graphs. I'll make another video to explain more about supply and demand curves, the law of supply and demand, and what in concepts consumer surplus and producer surplus is. Okay, all right, now I got to get back on track. Here's how we calculate this thing called the consumer surplus and this other thing called the producer surplus. It's really nothing other than the area between two curves on a graph. You see this region here that is above the equilibrium price. Okay, the equilibrium price is where the supply and the demand curves meet, but I won't explain that. That'll be for another video, but they do intersect somewhere, and that's called the equilibrium price. The region below the demand curve but above the equilibrium price is called the consumer surplus. The total area, the physical size of that space on the graph is the consumer surplus. And we can calculate that by a definite integral. So you can calculate the consumer surplus as the integral from 0 to Q1, which is the quantity associated with the equilibrium price. P1 is the equilibrium price, Q1 is the quantity associated with that. So we have the definite integral from 0 to Q1, and then you take the demand curve minus the equilibrium price. That will be the consumer surplus. This region B here, this triangular region, this region that's under the line that represents the equilibrium price but above the supply curve, that's called the producer surplus. And again, it's just the area between two curves. I've already made a video about that with some examples. But that is, you take P1, this line that represents the equilibrium price, minus the supply curve, and our definite integral is from 0 to Q1, the quantity associated with the equilibrium price. Okay, all right, so that's what consumer and producer surplus are. Without telling you the economics behind it any more than I already have. That's for another video. Okay, so let's look at an example. So let's say that in this example here, let me see, whoops, hold on just a second. Okay, so here's my example. Suppose that we have an equation for a supply curve, okay, which tells me at various quantities how much suppliers are willing to supply, and the demand curve, which tells me at various quantities and prices how much consumers are willing to buy. Okay, so that's what those are, and they look something like this. They'd intersect somewhere. They would intersect somewhere called the equilibrium point. Okay, all right, so that point right there, that's the equilibrium point where the supply and demand curves meet. Now, so that's what I have. Okay, and I know it looks something like this. At this point, I'm not telling you anything more than that. Now, with that being given, here's what I would like to find. The equilibrium point, which I explained in concept, that's where the supply and demand curves meet, and then the consumer surplus. Okay, so first, in order, let's find the equilibrium point. If that's the point where the supply and demand curves meet, then we could find that in principle by taking the supply curve, which that's right here, and setting it equal to the demand curve. All right, and whatever we solve out of that is this point where those two things meet. So when I solve this, I added 5 over 6 times q to both sides. I get 7 over 6q equals 7. I move the 1 over. That's how I get the 7. Then I multiplied both sides by 6, and I got 7q is equal to 42. Then I divided both sides by 7. I got q was 6, okay? So that says that this right here is 6, okay? That's like the x-coordinate, so to speak. And then if I take that q is 6 and I sub it in either one of these, why doesn't it matter which one I substitute my known value of q in? Well, because I'm trying to find a point that's on both the supply and demand curve. So I could take this first found value, q is 6, and sub it in either the supply or demand to find the equilibrium price. So I took 6, I put it in the supply, 1/3 q plus 1, you get 1/3 6 plus 1, and that's equal to 3. So for this equilibrium point, the equilibrium quantity is 6 and the equilibrium price is 3. Okay, or you could say that that point where the two intersect is 6 for the first coordinate and 3 for the second. Okay, all right, so there you go, equilibrium point. I'll write it here, 6 and 3. Okay, now next, consumer surplus. How would we do that? Well, let's go back up to the first page in the notes. Consumer surplus, you go from, it's a definite integral from 0 to q1, q1 being the equilibrium quantity, and then you take the demand curve minus p1, where p1 is the equilibrium price. Okay, so take that exact formula and you see it here. Okay, my integral is from 0 to 6. From 0 to 6, there's the equilibrium quantity. Then what you see here, 5 over 6q plus 8, that's the demand curve, and I subtract 3, which is the equilibrium price. So that's that exact formula that I have on the first page of the notes. This is a definite integral. Okay, I'll take the 8 minus 3, I'll combine that into a 5 right there. And here's my antiderivative, which is the whole key to evaluating a definite integral. Right there, negative 5 over 12 q squared plus 5q, okay? And then I put my bounds in. If you put 6 in, and then you put 0, you'll get 15. Okay, so 15 is the consumer surplus. And if it was given that our unit for the price was in dollars, then consumer surplus has units in currency, dollars, okay? All right, so That's how we can find the consumer surplus. All right, producer surplus is no different really, not any harder. It's just going to be P1 minus the supply curve. Okay, but let's look at another example. Um, let's take this one here, okay, where the information is not given in as quite a straightforward way, okay? So we have this more complicated demand curve. It says D equals 5,000 over 5Q plus 2 all squared. That's demand. And let's say that the supply curve is not given. Here I'm listing my halves, but I want to put under the halves the fact that we don't have a supply curve, okay? But it's also given that the equilibrium point is at Q being 4. So I'd imagine like, right here, this is demand. This curve that kind of slopes downward like that. And, I don't know what the supply curve is, but it's somewhere they meet each other, and that happens to be this point where it has a Q value of 4, okay? Now notice I've got this other value, 1250 over 121. Well, that's the second coordinate, the y coordinate, so to speak, that you get from Q is equal to 4. So if you take 4 and you put it into this, 5,000 over 5 times 4 plus 2 all squared, then you'll get 1250 over 121 if you reduce it, okay? So when I did this, I'm used to doing math with paper and pencil. I don't use calculators much and so on. But I did this on paper, and I plugged that number in, and I reduced it. I got 1250 over 121. Okay, so that's the situation that we have. And I want to find the consumer surplus. Okay, now even though this picture looks a little bit incomplete in that I don't have the supply curve, and I know that this first slide I showed you, I said here's the things that are involved: the supply curve, the demand curve, the equilibrium price. If all I need is the consumer surplus, then I shouldn't need any more than what I already have, okay? The reason is because it's just the demand minus the equilibrium price from 0 to the equilibrium quantity. Now, and I have all that stuff, okay? So here we go. My integral is going to be 0 to 4, because 4 is the equilibrium quantity, minus, what's that? That's demand, okay, 5,000 over quantity, 5Q plus 2 squared, subtract, and then this should be the equilibrium price, which I find by taking the equilibrium quantity given to be 4 and plugging it in to either the demand or supply curves. All right, but I got the demand curve, so I put it in there, so that's how I got 1250 over 121. Now, here's my definite integral. All I have to do to figure out what the consumer surplus is to work this out, okay? Now, for now, I want to give you this as the antiderivative, okay? And I'll show you in a minute how I got that. It's probably easy to see. How do you get from 1250 over 121 an antiderivative of 1250 over 121q? Well, because that's what the antiderivative of a constant is. You just attach the variable to it. But this other one I'll explain in a second, okay? But in any case, there's the antiderivative. Putting in 4 into this, and then 0, and subtracting, as we always do when we evaluate definite integrals, you get 413.22. Okay, let's suppose that the question, since this is currency, might say to round to the nearest penny or something like that. So 413.22 on my calculator. I got some other digits past that, but 22 cents, rounding it to the nearest penny. Okay. All right. So this one, yeah, it's same concept as that first one, but the information's given in a different way. All right. See the difference between them, between this example and between this one. All right, but nonetheless, I'm still able to work them ultimately in the same way. Now, one more thing. Here, I just told you that this was the antiderivative. I'll tell you how I got it, but I want to do that at this point. So it's not hard to find the antiderivative of 1250 over 121 because that's just a constant. I want to look just at this part that says 5,000 over 5q plus 2 quantity squared. So to do that, we can use u substitution. Okay, the way we would proceed, let u be 5q plus 2, this bottom part, that would make du equal to 5 dq. In order to substitute the dq out, I'll divide the 5. It says dq is du over 5. And in this step right here, making those substitutions, I get 5,000 over u squared is du over 5. 5,000 over 5 makes 1,000, a constant which I factor out. I'll pull this up with a negative exponent, and then we get, what, a real easy rule. Every time, I know I've talked about this in other videos, but we have a rule that is operative whenever we use u substitution, and I was going to take it down to this rule. X to the power n dx, antiderivative is x to the power n plus 1 over n plus 1 plus c. That rule is applicable here. It's just that the variable is u instead of x. So that will give me this and this. Okay, now when I use my antiderivative up here to evaluate the definite integral, I can always just ignore the plus c. Even if I wrote the plus c up here, it would just cancel out when I work this out further, so we just forget about it. Okay, so that's everything for the math behind the producer and consumer surplus. I'll make another video about the concepts behind this, laws of supply and demand, and I didn't explain what does consumer surplus measure. It must measure something about how all these things interact together. So again, that will be a separate video. But at least for now, this video summarizes how the math works out.